Hey guys, it's Vince with Keystone Metal. Today we're going to do another video on introduction to MIG welding. If you guys would like to follow along, you can check out any of the links below. Check out the equipment that we're using today, and we'll jump right into it. All right, so what is MIG welding? MIG stands for metal inert gas welding. It can be broken down into a couple different categories. GMAL is gas metal arc welding, and then you can also run flux, which is a gasless version, and that's going to be flux core arc welding, and that's FCAW. Basically what we're doing with this is we're either feeding a solid wire or we're feeding a shielded wire. The solid wire is going to be covered by shielding gas, and obviously your flux core wire is going to have the shield around the wire itself. So you can also weld aluminum and stainless steel with the process of MIG. Obviously both of those processes are going to require proprietary accessories and wire. So for aluminum you're going to want to run a spool gun, and then obviously for both you're going to have to run the proprietary wire for both of your alloys. So this is one of the reasons people tend to migrate towards MIG welding. It's very simple. All you got to do is set up a couple consumables and you can approach various different projects. Today we're going to focus on basic automotive references. We'll be using an 023 solid wire, and again we'll be using shielding gas to achieve all the results that we're after today. All right, so let's talk about some machine components real quick when you're MIG welding and some consumables that you guys might go through. We're going to start at the torch right here. At the end of the torch we have our nozzle. Usually this threads on, and this is what is going to control how much shielding gas is coming out and applying to your material. So it's important to keep this orifice clean. This will build up with spatter and BBs. You guys can use your welding pliers to clean it out, make sure it's always clean. And you can also use anti-spatter or a dip on this to make sure that it doesn't collect a bunch of spatter while you're welding. Moving down the torch here, we have an exploded view. This is going to be your contact tip right at the end here. It's important to make sure that you're matching your contact tip to the size of the wire that you're using. They come in various sizes, and if you have an oversized contact tip and undersized wire, you're going to get a lot of slop in there. It's not going to give you good results. So moving down, we have the diffuser. This is where your shielding gas is going to exit the torch. So you have 4 orifices around the diffuser. The shielding gas is going to come out of the orifice and travel down the nozzle, covering the material that you're welding. Inside of the diffuser, you're going to find a liner. This is a common culprit for issues as well. I see a lot of, in new welders, they're unsure of this fact, but what happens is if you kink your wire too much and you put a hard bend in the liner, because this is made out of metal, it restricts how freely your wire is going to flow through your torch. It can result in a lot of spatter, a lot of sputtering, inconsistent results in your bead, and it's just another culprit to keep an eye on to replace if you guys have any issues. All right, so next up we have our ground lead here. This is pretty important and also overlooked sometimes. You're always going to get your best results if you can keep your ground lead as close to the material as possible when you're welding. The other important thing is if you can't get it directly to the material, if you have a metal table like this that you can ground to, that's going to work fine. It's just imperative that you make sure the ground is clean. You don't want to ground this to a rusted part of the table. You don't want to ground it to somewhere that has paint or something like that, because you will notice inconsistent results during your weld if you don't have a good ground. All right, so let's talk about gas for a second. Today we're going to be running a C25 mix. C25 is 25% carbon dioxide, 75% argon. We're going to be using this for most of your automotive. Anything that's carbon steel, this is going to work for you, and you can also use it on stainless just by switching the wire like we mentioned previously. Some other gas mixtures that you guys could experiment with are C100, which is 100% carbon dioxide. It's also a good choice for automotive and carbon welding. It's just going to be a little less controlled on your arc, and it might create a little bit more spatter. So a little bit overall of a more messy weld, but still usable for most of the stuff that you're going to see on this channel. The other things that we can do is C2 mix, which is 2% carbon dioxide and 98% argon, and then a tri-mix of helium, carbon, and argon. So anything under 10% carbon dioxide is usually good for more structural welding, spray transfer, spray arc, stuff like that. A little more in-depth stuff that we're not going to touch on today. Today we're going to focus on the C25 mix, and we'll show you some results with this. So every gas bottle that we're going to use requires a regulator to set your CFH, so let's take a look at that. All right, so here we have our regulator. So this is going to screw into your gas bottle, and then the other end of your gas line is going to screw into your welder itself. Typically, you're gonna have two gauges on your regulators. One of them is gonna show the poundage in your tank, and the other one is gonna show your CFH, which is your cubic feet per hour. This is your live flow gauge of how much shielding gas is coming out of your torch while you're welding. And this gauge here that shows PSI is showing how much gas is remaining in your bottle. All right, so on your flow meter here, you're gonna see that there's a red and a black gauge. They're two different gauges. One of them is pounds per minute, and the other one is your CFH, which is cubic feet per hour. So when we're setting this up, we're gonna be running about 10 to 15 cubic feet per hour on carbon steel. When you're MIG welding, you can run anywhere between 10 and 25 to 30 CFH, depending on the material that you're at. So it's always good to just make sure that you're referencing the right gauge when you're setting your flow. All right, so what I'm gonna do now is activate the trigger. We'll see the flow meter move, and then I'll show you how to adjust it from there. Okay, so you can see when I pull the trigger and activate the machine, the gauge on the flow meter moves. The way that we're gonna adjust that is with this knob here in the front. So as I pull the trigger, activate the shielding gas, and it's coming out, I can activate this right or left to increase or decrease the amount of flow that's coming out of our machine. All right, so real quick, we're gonna go over the controls on the machine. I'll run through what all this stuff does for you. So our two main controls are gonna be wire feed and voltage. In layman's terms, voltage is your heat, and wire feed is how fast you're feeding your wire out of your gun. This is usually measured in inches per minute, and obviously your heat, again, is measured in voltage. So we have a couple other settings on this machine. If we switch to this is your spool gun setting. So this is what you're gonna use to weld aluminum. If we go back to our regular torch, this is what you'll use for everything else: carbon steel, stainless steel, etc. And then over here on the right, we have 2T, 4T, and tack. And basically what this is 2T means that if I pull the trigger, it's going to feed until I let go of the trigger. If I switch it to 4T, I'm gonna pull the trigger and release it, and it's gonna continue to feed until I pull the trigger and release it again. So if you have a circumferential weld, or you're welding something on a position or a turntable, something that may take 2 minutes to weld, you set your machine to 4T, pull the trigger, it's gonna feed until you're ready to stop. You'll pull the trigger again and it'll stop. And then down here, if you switch it to tack weld, this is just gonna give you a repeatable tack setting. So if you have to do panels or something like that on a vehicle, this is a good aid for that. So for any of these settings, there's also a quick reference guide on the inside of this machine. All you're gonna have to do is input your material that you're welding with, and the size that you're working on, and the gas that you're using, and this is gonna give you a good ballpark to start in. All right, so we're gonna jump into the inside of the machine here. I'll break this stuff down for you and what you guys are looking at. So right here you have your spool. Your spool wire is gonna slip over this. You have a wing nut that's gonna tighten it up. One thing to touch base on with this is that you guys wanna make sure that when your wire's exiting the roll, it has the least resistance before it enters your liner here. So if you have this feeding around the top and it comes down and then a hard turn into your wire, you're probably going to experience more issues than if you had it exiting the bottom here, and then you have a straight transition into the liner. So once we enter the drive roller here, what you're going to see is you have a roller on the top and the bottom, and you have your tension adjuster right here. So this is going to have a bunch of different numbers on it, usually 1 to 5, 1 to 6. And depending on what the wire is that you're running, this is going to be your tension adjuster to squeeze the wire to feed it. If we open this up, you'll see your wire sitting inside your drive roller here. Most of the time these are double-sided, so they're going to offer 2 different sizes of wire. It's crucial to make sure that when you install your drive roller, the groove in the roller is adequate for the size wire that you're actually running. Once you thread everything in, you'll close the roller, set your tensioner, set your tension on the roller itself, and you're good to go. All right, guys, so to dive into PPE again, personal protective equipment, as always, protecting your eyes when you're welding is crucial, not only for your health, but also for good results on the bead. So these 2 helmets right here, we have 2 different versions. One is a more inexpensive version than the other. Obviously, the more money you spend, the more features that you're gonna get out of the helmet. So this one on the right is gonna offer a bigger viewing shield for you. Both of these helmets are auto darkeners. This helps a lot when you guys go to initiate your arc. You don't go blind for that second you're putting your helmet down and then initiating your arc. So I always recommend a good auto darkener when you start out. Something with a shade from 5 to 13 is great. That's gonna cover you from heavy duty welding all the way down to doing something simple as cutting, grinding, plasma cutting, oxy cutting, whatever. So it's good to have that adjustment in your helmet. It also offers a good delay. So when you guys are welding, as soon as you finish, if your weld is still cherry hot and you lift your helmet up and you look at that, that can also cause damage. So having a delay on the helmet that won't shut off your auto darkening setting until your weld pool has cooled down a good bit, that's a good feature as well. The reason we stress picking up a good helmet, obviously arc eye or welder's flash is a big concern in the welding community. Basically what happens is if you look at an arc with your bare eye, 6 to 8 hours later, you're gonna experience some pretty nasty symptoms. It can wake you up out of your sleep, and it just feels like you have sand and grit in your eyes. No matter what you do, you can't get it out. It'll ruin your sleep, ruin your productivity for the next day at work. So again, invest in a good helmet, obviously for your health, and then the better and the clearer you can see, the better you're gonna be able to perform as a welder. Next up, we have a jacket. I always recommend a fire-resistant jacket. This is gonna protect you from sparks, UV light, from UV light's always emitted from the welding process. So no matter what you're doing, you always wanna cover up your skin to prevent skin cancer, blisters, or sunburn, which is exactly what you'll experience, the same kind of reaction on your skin that you would get if you were sitting on the beach too long. So always important, protect your hands, your face, your neck, your skin, anything that's exposed to the arc you want to keep covered. All right, so continuing to talk about our PPE, we'll move on to gloves here. We have 3 different styles in front of us. Starting on my right here, this is your heavier duty standard, what you're going to see for MIG welding. This is going to protect you against the heavier sparks. Moving over to our left, this is what we would typically see for TIG welding. It's a little bit thinner up here. So this type of glove is going to give you a little bit more dexterity and a little bit more mobility with your fingers. You can get by with this. MIG welding with these isn't an issue, but typically what you're going to see, like these gloves here, they have a lot of spatter marks on it, and eventually they will wear through this, and you might catch your skin. So using TIG gloves is fine for MIG welding, just short periods, and you're going to want to switch them out as they get too thin and start to burn you. If you're in a pinch, you guys can switch to regular mechanics gloves, automotive gloves, anything that's going to protect your hands. These have a little bit of padding on them, so if a spark falls on there, probably going to protect your hands a little bit better than something like a latex glove. Obviously we wouldn't recommend that. It can melt, and once a rubber or something like that melts to your hands, it's very painful. Even after you remove it, still a problem. So stick to a high quality glove, something that's leather, kid skin, goat skin, something like that. It's going to protect you. It's a good way to go. All right, so let's get into technique a little bit, how to hold a torch and what to expect when you're welding. So there's a lot of different ways to do this. One common mistake that I see with new welders when they're trying to MIG weld is they try to hold it with one hand and control everything like this. Makes it pretty difficult to get consistent results. I always like to rest it on something, whether it be some kind of arm bar or my hand or my arm itself, whatever it is. It's going to give you more consistent results. So one common thing that you'll see people do is rest it over their wrist, rest it over their palm. And then my specific choice, what I like to do, and this is just personal for me, is I like to do what's called like a reverse pull cue. So normally when people shoot pool, they'll shoot it like this, and basically what I do is I just take my wrist and turn it, and I put my torch here in between my index finger and my thumb right in the crevice here. That allows me to move everything, go up, down, left, right, however I have to do it. And my 4 fingers are always going to keep me pretty much the same distance away from the material that I'm welding. So the next thing that we'll dive into is your stick out. The easy way to do that, pair of welding pliers right here. These are going to give you actually 2 different settings of stick out. So if you go on the cutting side here, you can shorten it all the way to the nozzle, and if you go 180 degrees with the welpers, stick it in, bottom the welpers out, make your cut. You're going to get the same stick out every time. It's roughly a 1/4 inch, maybe 3/8 there. If you want to flip it over, you can go even shorter. Get it flush with the nozzle there. This is something that I do after every single weld, and it gives me consistent stick out. And what it also does is no matter when you MIG weld, you're usually going to end up with a ball on the end of your wire. So it ends up being a little bit thicker. It can throw off your starts, or if you're tying in, it can throw off your tie-ins, which is usually pretty important. So what I like to do is after I do every pass, whether it's an inch or 10 inches of weld, make sure you're snipping your wire and you're running the same stick out every single time. So again, we'll touch on comfort. I like to talk about the ABCs, always be comfortable. 2 things, your body positioning, your hand positioning, and then your vision, obviously, being able to see clearly. So touching back to the helmet, get a clear helmet that allows you to see everything. That's going to allow a good pass. And then having comfortable body positioning is going to aid you tremendously in all your welds. So usually I like to take the weight off the torch, lean on something, give yourself something stable to move on so that you're not floating around. All right, so let's piss some people off. We're going to talk about push versus pull. So two techniques that most people are going to approach is your push versus your pull. If you're right-handed, if you're left-handed, depending on what you're welding, you may have to do both. Typically, when you push a weld, you're going to get better results. You're going to get better penetration. You're going to drive your wire into your material a little bit better. But when you pull your weld, most of the time it's going to help a new welder see what they're doing. There is a little bit of difference, but ultimately it's not going to matter too much. If you're getting the results that you need, you have good penetration, your weld is solid, it's going to hold. I don't think the approach that you take really matters too much. You're looking for good penetration during your weld pull, and you're looking for good consistent results throughout, and it's going to work either way. There's certs for both. You know, no matter what process you choose to use, as long as you get good results, that's all that matters. All right, so we'll talk about torch angle real quick and different ways to hold your torch to get good results here. Obviously, one thing that we want to focus on is containing our shielding gas to the material itself. So I typically don't like to exceed a 45-degree angle. Anything under that is okay, depending on if you're pushing or pulling. Again, whichever way you're welding, you want to make sure that your shielding gas is covering your pull. So ideally, if you can go straight on, go straight on. If you have to cant a little bit, 15 degrees, 30 degrees, that's okay. If you're pulling or pushing, it's important to know that if you're pulling, you can go up to 45 degrees and you're still going to get all the coverage on the weld behind you. If you're pushing and you're canted pretty hard, as soon as you get past a certain point, you're going to cut off shielding gas to the weld behind you. MIG welding, it's not as crucial as TIG welding, but it is something to keep in mind while you're welding. All right, so real quick, we're going to talk about the movement of the torch itself while we're mid-weld. All right, so just using the Sharpie on this table, I'm going to show you a couple techniques that we use. The first one, and the most common one for learning, I would say, is the cursive E technique. So when you're drawing your weld puddle, basically what you're going to do is just draw a bunch of cursive E's like this with your torch, and eventually you can run a 50% overlap on them like this, and that's what's going to give you that stack dime effect right there. So after you try this, another one that you can try, which is a typical technique that I'll use for welding two different thicknesses, is a wave technique, or what's called a whip and pull or whip and pause. So basically what you're going to do here is you're going to initiate your arc, you're going to come over, you're going to whip, you're going to pause here, come over, whip, pause. Some people will call this the wave technique too. Basically what you're going to do is you're going to initiate your arc and keep most of your heat onto your thicker material, and then use your wave technique to wash up to the thin stuff real quick and then come back down to the thicker base metal. All right, so we're going to dive into metal preparation and how to clean your metal before you approach the weld. So there's a couple things to look for if you guys are dealing with carbon steel, mild steel, whatever it may be. You want to check for things like oxidation, rust spots, or mill scale that may be on it from the manufacturer. Other things to look out for are lubricants and oil, stuff like that they may be coated in before they get shipped. So very important, we want to make sure that we clean everything off. There's a couple different ways that you can do it. You can use a wire brush, you can use roll-lock discs, flap wheel, sanding disc. You can put on an angle grinder or a die grinder. You can also take your brush here. One thing I want to note is when you are brushing any impurities off of the material, I always like to brush in the same direction instead of coming back and forth and kind of just digging the impurities or the imperfections into the material. So you'll just take your brush, go in one direction, straight, and just do this over and over until you've removed any rust spots, any oxidation spots. And then if you have something a little bit heavier duty that you need to remove, like mill scale, you want to turn to some kind of air tool or power tool to remove that before you start welding. All right, so after you brush it, or you use one of a power tool or a pneumatic tool to clean the surface, take your pre or your acetone, and you're just going to wipe it down real quick. Make sure you have a nice clean surface before you start welding, and you should be good to go. All right, so now we're going to jump into the different types of welds that we're going to do. Right now we're going to show you 4 different types. We're going to start with a butt weld, we'll do a lap joint, a T-joint, and then we'll jump into some plug welds for you as well. All right, so to start with a butt weld, basically what we're looking for is to keep good eyes on our joint. And we kind of just want to flip this 50% on each side of the joint. We're going to do 50% overlap on our bead here using the cursive E method. And we're kind of just dragging our puddle right back on top of our previous bead. All right, now let's do some lap joints. All right, so for a lap joint, we're gonna try the same practice here. We're gonna go 50% up and 50% down, kind of just hanging out on that toe of the lap at the top, overlapping our bead by 50%. Practicing the cursive E method here. And on a lap joint, you're just going right up to the toe and then stopping and coming back down to your base metal. All right, so next up, we're gonna do a T-joint. All right, so approaching a T-joint, again, we're gonna share the puddle about 50% of each, and both of these coupons are the same thickness. And what I'm doing is just walking up to the top piece, and again, 50% overlap, down onto the bottom piece, and repeat. All right, so next up we're gonna jump into some plug welds. This is probably most commonly what most people are gonna see when they're doing automotive work. Rockers, cab corners, all your body panels, stuff like that. Most of the time it's usually plug welded, so we're gonna jump into a quick demonstration of how to plug weld. It's fairly quick, fairly simple, just in and out. You're just filling a hole, trying to get your base metal on the back side to pretty much be flush with the holes on the top piece of material that you have. All right guys, so when we're approaching a spot weld here, basically there's a couple different ways to do this. You could start in the center and then walk your way out and do the perimeters. Or you can start on the perimeter and walk your way in. I'm gonna light up right in the center of the plug. As soon as I establish my puddle, you'll see me walk north. Once I hit my 12 o'clock metal, I'm gonna walk counterclockwise and just do a circle right around to fill it in.